Hello, my dear students. Before we start with today's session, I would like to tell you something. Learning. So, we are learning so many concepts in mathematics, right? From class 11th, class 12th, so many topics we are learning, so many concepts we are learning. Obviously, this is useful where it is used in the applications, in the practical life, as well as in your higher studies. But what does learning lead to? So, we are learning so many new things. Learning gives you creativity. Okay? So, creativity means thinking out of the box or thinking in a very creative manner. So learning gives you creativity. And what does creativity gives you? So learning gives you creativity. And what does creativity leads to? Creativity leads to thinking. Correct? Creativity leads to thinking. And what does thinking provides with? Thinking provides us with knowledge. Thinking provides us with knowledge. So once you get your knowledge, and what does knowledge makes you? Knowledge makes you a better human being and also makes you very great. So these lines, whatever I have written on the board, I am not telling these lines. Okay, these lines are quoted by the great Mr. Dr. APJ Abdul Kalam. My name is Karthik. Welcome to Vista's Learning. In today's session, we'll be discussing about the fourth topic of class 12th mathematics, that is determinants. So today will be the last session of the synopsis. So we'll be having a look at some applications of determinants. Means whatever we have studied determinants in the previous classes, so those are the topics which we have studied in the fourth chapter. Now we are going to see whatever we have studied that, where is it being used in the actual world, or practical application of those determinants is what. So that is what we are going to see today in our today's session. So starting with the very first one, applications of determinants. Now students, determinants we have studied many terms, or terms related to determinants also we have studied, like, so for example, what are cofactors, what are minors, and what is an adjoint, what is a determinant, how to find out a determinant, what is a principal diagonal. All those things we have studied in the determinant. So in today's class, what we are going to see is where are these determinants being actually applied and how are we getting the solutions for that. So students, determinants are being applied. So there are two applications of this. So very first one is to solve linear equations. Okay, so linear equations can also be solved by elimination method as well as cross multiplication method, which you have studied in your class 10th. So by that method also we can solve the linear equations, but we have studied determinants, right? So by using determinants, what are we doing? We are trying to solve linear equations. And the second one, so applications of determinant is also used to determine whether the system of equations are having consistent or inconsistent solution. Understanding? The system is having consistent or inconsistent solution. What is the meaning of consistent solution? Again, there are two types in that. One solution, unique solution, or more than one solution. Inconsistent means no solutions at all. So now this has been discarded from your syllabus. So we'll be having only a look at this. Anyways, you will be studying this in your higher grades. So this is 12th class, right? 12th class we are only studying point 1, that is how to solve a linear equation by using determinants. About point 2, this is right now discarded. Okay, about this you'll be studying in your higher classes. So let us begin with this. How to solve linear equations we'll see on the left hand side. So we will take one small example, students. a11x plus a12y is equal to z. 1 will take, and a21x plus a22y is equal to z2. What is this? This is the two variable linear equation. So how do we solve this, students? So this entire thing can be written in the form of matrix A into matrix X is equal to matrix B. So what is matrix A here? So these things are matrix A, students. See this? 1, 2, 3, 4. So these are the things which you have to write it in matrix A. So just write that down. A11, A12, A21, A22. So this is our matrix A. And what is matrix X? Matrix X is nothing but, so these are matrix X. So just write it as it is, X, Y. And what is matrix B? The right hand side. So those are the values of Z1 and Z2. So what we have to actually do here, we have to solve this linear equation, right? To solve the linear equation means you have to find out what are the values of X and Y. Now to find out what are the values of X and Y, what we will do here is, we will send this A to the right hand side. What happens to the A when it goes to the right hand side? So this will be equal to, matrix X will be equal to inverse of A into matrix B. Now what is inverse of A, students? What is A inverse given by? A inverse is given by adjoint of A divided by determinant of A. Where did we learn this? Chapter 4th, determinants. So what is the formula here? Adjoint of A divided by determinant of A. So this will be one matrix, and there is already another matrix there, that is matrix B. Multiply these both things, you will be getting the X and Y values, which means we have solved the given linear equation. So understood? So these are the applications. So these both are the applications of determinants, and in class 12 and in this session we will be only covering this, because this has already been deleted from your syllabus. I hope you understood this. The same procedure, whatever we have seen, so here there are only two equations, correct? The same thing and two variables, right? X and Y, X and Y. Two equations, two variables, or we can also call them two unknowns. Now the same thing is applicable to three equations where there are three variables, X, Y and Z, and there will be three unknowns, that is nothing but X, Y and Z. The same procedure is applied also for three equations. So we have understood this. So this is the theoretical part only. How is applications of determinants used in solving the linear equations? So we'll see few examples, students. Okay, moving on to the next one. So solve the system of equations, and they have given 2x plus 5y is equal to 1 and 3x plus 2y is equal to 7. Now students, here what you can do is multiply this with 3, multiply this with 2. Okay, you can eliminate x, find out what is y, back substitute y and find out what is x, and you will be getting x and y. Very easy. Which method is this called as? This is called as elimination method. But what are we going to see? We are going to see how to solve this particular given equations with the help of determinants. So this can be written as what, students? Matrix A into matrix X is equal to matrix B. Correct? What is A? The numerical coefficients. So that is nothing but 2, 5, 3, 2. Understood? And what is X? The variables, unknowns. X, Y. Which is equal to, what is B? The right hand side, that is 1 and 7. Do the matrix multiplication here, students. How is matrix multiplication done? First row into first column, first row into second column, first row into third column, and goes on like that. So first row into first column, 2 into x, 2x, 5 into y, 5y is equal to how much? 7. We're getting the same thing, right? See the next one. Second row into first column, 3 into x, 3x, 2 into y, 2y is equal to 7 again. Correct. Now we have to find out what is x and y. Send this on this side. What will happen? X, y will be equal to 2, 5, 3, 2, the whole inverse into, what is b, students? 1, 7. Now check out the orders. See whether you can multiply them or not. So what is the order here? 2 cross 2. And what is the order here? 2 cross 1. Can we multiply them? Yes. Why? Because the number of columns in A is equal to the number of rows in B. This condition is getting satisfied, which means we can multiply these both matrices. But will you multiply 2 into 1 and 5 into 7? No. So see, we have this inverse, right? So what is A inverse? So now this is in the form of x is equal to A inverse of B. How do we find out A inverse? Adjoint of A divided by determinant of. And how do we find out adjoint of 2 cross 2 matrix, students? I think you have remembered that I have taught you one shortcut. Interchange the principal diagonal elements. So therefore we can write A inverse is equal to, what is adjoint of A? Interchange the principal diagonal elements. So both are same. So write that as it is 2 and 2. And interchange the signs of the second diagonal or this diagonal. Interchange the signs only. So this will become minus 3 and this will become minus 5. So this is minus 3 and this is minus 5. Adjoint of A is done. Divided by determinant of A. So what is the determinant here, students? So that will become 4 minus 5 3 is 15. So that is equal to minus 11. So this is minus 11. So this is our, what did we get here just now? We got our A inverse. So this again can be rewritten as what? So we'll rewrite it like this: x, y equals minus 1 by 11 of 2 minus 5 minus 3 2 into, what is B matrix? 1 and 7. What we have got now? We have got the A inverse, exact A inverse. Now multiply these both matrices and scalar multiply this scalar product, that is minus 1 by 11. So again in the next step we can write minus 1 by 11 as it is. 2 into 1, 2 into 1, this is matrix multiplication, students, what we are doing here. 2 into 1 is 2 plus minus 5 into 7. So minus 5 into 7 is minus 35. Minus 35 plus 2 is equal to how much? Minus 33, correct? 2 minus 35 minus 33. Next, minus 3 plus 14. Minus 3 plus 14 is equal to plus 11. Write that plus 11 as it is. So what is this? This is our product of these both matrices. When you multiply these both matrices, this will be your product. Now scalar multiply whatever is there outside. So here you will be getting 3, correct? Minus and minus, it will become plus. Minus into minus is plus. 11 ones are 11 threes are. The same thing, 11 divided by 11, this will become minus 1. So what are these actually? This is your x value and this is your y value. Understood? So once you get the values of x and y, to check whether the answers are right or wrong, okay, once you get the values of x and y, to check whether these answers are right or wrong, what you have to do is back substitute these values 3 and minus 1 in this equation. So x is equal to 3, y is equal to minus 1. Back substitute these values in this equation, see whether you're getting the right hand side. 2 3s is 6, 5 into minus 1 is minus 5. So 6 minus 5 is equal to 1, satisfying. Check for this also, students. 3 3s is 9 into minus 1. So 9 minus 2 is equal to how much? 7. So it is satisfying, which means these values are right and the procedure what we have followed here is also right. So students, this is an application of determinant, finding out the unknown variables in the given equation. So this was for only 2 equations were given and 2 unknowns were there, correct? We'll take up another example where we have 3 equations and 3 unknowns. Same procedure only to be followed. So the next problem, solve the following system of equations by matrix method. So same thing we have to do. What should we write? Ax equals b. Later on we have to write x is equal to a inverse of b. Okay, we'll directly write this step, students, now. Okay, we'll write this step first. So what is a? A is nothing but the numerical coefficients 3, 2, 4, minus 2, 1, minus 3, 3, minus 1, 2. And what is our x, students? X, y, z. And what is our b? B is nothing but 8, 1, 4. This is in which form? This is in the form of ax equals b. Okay. Now we have to find out the values of x, y, z. 3 equations and 3 unknowns, correct? X, y and z. Send this on that side. What will happen? X is equal to a inverse of b. Send this on that side. What will happen, students? So here we'll write x, y, z is equal to a, the same matrix, inverse of b matrix. Now what is A inverse, students? We know already what is A inverse. A inverse is nothing but adjoint of A divided by determinant of A. So let us find out, to find out A inverse now we have to find out adjoint of A. So adjoint of A, what is the very first step? We have to take the transpose. After taking out the transpose, we have to find out the cofactors of each and every element. The resulting matrix what we get after doing these both steps, okay, that is called as what? That is called as adjoint of A. So that should be divided by determinant of A, then we'll be getting our A inverse matrix. So once we get our A inverse matrix, multiply that with matrix B and you'll be getting the values of x, y and z respectively. So as simple as that. Procedure looks a little bit lengthy. This is time consuming, but this question will be asked for 4 marks in your examinations. Okay. So 3 variables in subjective means in your boards, and 2 variables means the previous problem in your objective means competitive examinations. Understood? So let us begin with this. Find out the transpose of the given matrix A. So the transpose of the given matrix A can be written as 3 minus 2, 3, 2, 1 minus 1, 4 minus 3, 2. So this is the transpose of the given matrix. Now let us find out the cofactors of each and every element. So what is cofactor again? Cofactor is nothing but minus 1 whole to the power of 1 plus j multiplied with the minor. And what is minor, students? How do we get minor? So if you want the minor of 3, this row and this column is gone. Whatever elements are remaining, put them inside a determinant. So if you put this inside a determinant, you will be getting, okay, so if you put this inside determinant, you will be getting 2 ones are 2, plus or minus. Minus into minus is becoming plus. The default sign in between the determinants is minus, correct? So 2 minus 3 is minus 1. What is the sign here? So signs also will write down there. So we'll write down the signs like this: plus, minus, plus, minus, plus, minus, plus, minus, and plus. So these are the signs. How did we get the signs? Aij minus 1 whole to the power of I plus j. So now what did we get here, students? 2 minus 3 is minus 1. Minus 1 multiplied with the cofactor, that is plus. So here we'll be getting minus 1 only. Next, these both are gone. Minus 4 plus 9. Minus 4 plus 9 is plus 5. Plus 5 multiplied with the cofactor, it will be minus 5. So these both are gone. Now we are finding the cofactor of 4. So that is becoming 2 minus 3. 2 minus 3 is minus 1. Minus 1 multiplied with plus. So we are getting the answer as minus 1 only. So you have to be very careful, students, when you are finding out the cofactors, because one small mistake either in multiplication or in the sign, the entire question will be wrong. Okay, so minus 1, minus 5, minus 1. Next, minus 2, finding out the cofactor of minus 2. So minus 2, if you do 4 plus 4, that is 8. 8 multiplied with the cofactor, that is minus. So this is becoming minus 8. Next, 1. So that is becoming 6 minus 12. 6 minus 12 is equal to minus 6. Minus 6 multiplied with the cofactor is plus. So we are getting minus 6 only. Next, minus 3. So this is becoming minus 3 minus 6. Minus 3 and minus 6. That is equal to minus 9. Minus 9 multiplied with the cofactor, here it is minus. So it will become plus 9. And write that back. Now cofactor of 3. Cofactor of 3 is minus 6 minus 4. That is equal to minus 10. Minus 10 multiplied with the cofactor, here again, what is the sign here? Plus. So that is becoming minus 10 as it is. Minus 6 minus 4. Next, minus 9 plus 8. Minus 9 plus 8 is minus 1. Multiplied with the minus sign, here again it will become plus 1. Minus 9 plus 8, minus 1, minus into minus is plus. Next, for cofactor of 2, 3 plus 4. 3 plus 4 is equal to 7. 7 multiplied with plus is again, we are getting 7. So what is this? This is our adjoint of A. Now what is determinant of A, students? So we'll find out the determinant of A here next. So the determinant of A will be 3 of minus 1 minus 2 of minus 5 and plus 4 of minus 1. So how did I write it very quickly? Same thing. See, minus 1 I have written here. Same thing, minus 1. Minus 5 I have written here. Minus 5. And minus 1 I have written here. Minus 1. So we can take this only, students, directly. Why? Because 3 that we have written here. Plus also we have written. So this determinant, right? Determinant of this. So work that out. 2 minus 3. That is minus 1. Same thing. So that is what we have written here. So these things only you can substitute. Now work out this. You will be getting minus 3 plus 10 minus 4. So that is equal to minus 7. So 3 is the determinant. Determinant of A is nothing but equal to how much? 3. Now that is it. We have to send A on that side. A inverse of B. So here we'll start working out for x, y, z values. So x, y, z equals 1 by 3 of minus 1, minus 5, minus 1, minus 8, minus 6, 9, and minus 10, 1, and 7. And what is B, students? B is nothing but 8, 1, and 4. 8, 1, and 4. So this is 3 cross 3. This is 3 cross 1. The number of columns in A is equal to the number of rows in B, which means we can matrix multiply them. So matrix multiply. So 1 by 3 as it is we'll keep. Minus 8, minus 5, minus 4. Minus 8, minus 5, minus 4, minus 12, minus 17 we are getting here. Okay, minus 8, minus 5, minus 4. So we'll just cross check this once again, the adjoint of A. Okay, so 3 if you take 2, minus 3 is minus 1, this is correct. If you take 2 again, so this is minus 4 plus 9, minus 4 plus 9. So that will be equal to minus 4 plus 9 is plus 5 into minus is minus 5. So here again next 4. So this is becoming 2 minus 3. 2 minus 3 is minus 1. So that is right again. So minus 1, minus 5 and minus 1. We are getting minus 17. 8, 1 and 4. Okay. Next. Minus 8 into 8 is minus 64. Minus 6 into 1 is minus 6. 9 into 4 is plus 36. So this is becoming minus 64 minus 30. So this is becoming minus 64 plus 30. So this is becoming minus 34. Understood? Moving on to the next one. Minus 10 into 8 is minus 80. 1 into 1 is plus 1. And 7 into 4 is plus 28. So 29, consider it as 30 students. So 80 minus 30 is minus 50. So, but less 1. So 29 minus 80 plus 29. Minus 80 plus 29. So this will give us 30, 41, 51. Yeah. So here we'll be getting how much students? Minus 51. Okay. Once we'll also check this minus of 2. We'll check this determinant, students, the value of the determinant. So here we have taken the value of, okay, so see here, this determinant value, whatever we have taken, we got the answer as 3. This we have taken it for this matrix. Okay, what is this matrix, by the way? That is already transposed. So students, the transposed matrix determinant value is equal to 3. Actually, we should not take this. What is A inverse formula here? A inverse is equal to adjoint of A divided by determinant of A. What we have taken the determinant of? The determinant we have taken is A transpose. We have to take the determinant of A. So this is, okay, not the right one. So we have to take the determinant from here. So here we see 3 of 2 minus 3. 2 minus 3 is minus 1. Okay, minus 2 minus of minus 2 of, so here plus minus plus. So this minus is from the sign and minus 2 as it is. So what will be getting inside? 4 plus 4, that is equal to 8. You've written minus 5 here because we took the determinant of the transpose student. Determinant of the transpose must not be taken. We have to take the determinant of the given matrix A. So minus of minus 2 plus 8, finally we'll be getting plus 3 of minus 6 minus 4, that is nothing but minus 10. Solve this now, this will be your determinant. So that is minus 3, minus into minus is plus, 2 into 8 is 16, so plus 16, and this will become minus 30. So directly what we have, minus 33 plus 16 students. Minus 33 plus 16 is equal to minus 17. So minus 17 is our what? Minus 17 is our value of our determinant. So here you have to write minus 17, minus 17. Now multiply this inside, what will you be getting? 17, 17, 1, 17 2s are 34, 17 3s are 51. So therefore these are the values of x, y and z. If you want, you can cross check these values by back substituting these values in the equation 1, 2, 3 students. So this is 1, this is 2, this is 3. Check whether you're getting 8, 3, minus 4, minus 1, minus 1 plus 9, 8. Means the values of x, y, z, whatever we found out by using this procedure is actually satisfying the given equations. Understanding? So these are the applications of determinant. So this will be the end of the synopsis of chapter 4, standard 12. In the next class, we'll be connecting you with the NCERT problems. Until then, stay tuned with Vista. Thank you.